Hi, you sevens. While I'm at the netball, what you're going to be working through is perimeter. So you would have done some of this at primary school, and I could clearly see in your pre-test that a lot of you were very familiar with this concept. So what is it? It's the total length around the outside of a closed two-dimensional shape. Okay, so the shape is going to be drawn on a flat surface and it has to be closed. And what that basically means is that if I asked you to find the perimeter of this, you would say, well, I can't do that because it's not closed. So the shape has to be closed like so. Okay. So a lot of people also think that shapes have to be drawn as what's called a polygon or have straight sides only, but it actually can be curved sides or even free-form edges. So all of these are examples of scenarios where I can find the perimeter. So for example, this triangle here, I just move my way around the outside of this closed shape, and that would be my perimeter. Excuse the bad drawing. Right, so this one here, this semicircle, I'd just go around the circle like so, okay, and then back up here, and I'd add up the total distance I've just covered, and that would be its perimeter. This jigsaw piece here, I'd move my way around, etc., etc. Okay, I'm not going to finish that one. And this star shaped here, I would just move my way around. And again, what I'm doing is I'm just calculating the distance I would travel all the way around that shape. I'm just going to speed this up a little bit dodgy there, and back to the start. So the distance around it would be its perimeter. So what we'll do is we'll apply this to 3 examples, and I just want to make sure that you remember this little tip here. Ensure you're operating in like units before finding perimeter, and that means basically ensure that all of the units in the shape you're operating on are exactly the same, whether it's meters or centimeters or millimeters or kilometers. It doesn't really matter which one as long as it's the same. Okay, so find the perimeter of each of these shapes. So again, it's just basically saying what's the distance on the outside part of this shape. Alright, so the way I'm going to do it is look at this part here and note that this distance is 3. Okay, so I'm going to write P equals 3 plus. Now I'm going to get this distance here, which is 5 plus. And I've noted here that they use these check marks here, or I'm not sure what they are actually called, but what they basically indicate mathematically is these two side lengths here are exactly the same. So this is also 5 centimeters. So it'll be 3 centimeters plus 5 centimeters plus this distance here, which is 5 centimeters. Alright, so that's going to be 10 plus 3 is 13, and let's not forget the unit, it's 13 centimeters. So the distance around this triangle here, it's an isosceles triangle, is 13 centimeters. Alright, what about this one? So let's write out P equals, and we just do a quick check of the units, and they're all in meters, so that's fine, we're ready to go. So let's start adding together the units. So we got that one there, which is 6, this one here, which is 3, this one here, which is 5, and this one here, which is 2. Alright, so we've actually got some other side lengths that we haven't included yet. So I'm going to switch to a highlighter and just indicate, no, it's not the highlighter. I'm going to indicate which ones we've got left over. So we've got to do this side here. Alright, now because I can see that this distance here from here to here is 6, then this distance here would also be 6. Now I know it's 2 to there, so that's this bit here must be whatever's left over to match 6, and that has to be this distance here. Okay, so this one has got to be 4 meters, okay, because if I look at this distance here, 2 and 4, I'm going to get 6. Alright, now the other part that I'm interested in is the base of this part here. Alright, and what I can see here is if I look at this part here, that's 3, and I can see this part here, and that's 5. So the distance along here must be 3 plus 5, and that's 8. So we can tack those other two distances on. So we need to include the 4 meters and we need to include the 8 meters along the bottom. And so when we stick that together, what do we got? 9, 14, 16, 20, 28. And don't forget the unit, that's meters. Alright, so the last example we'll do is this one here. It's rather big, so I'll just reduce the size of that a little bit. Okay, so the first thing you'll notice is that we've got different measurements here. This is in centimeters and this is in millimeters. Okay, so we've got a couple of choices here, and I'd prefer to work in millimeters because if I convert the millimeters to centimeters, I have to work with decimals, and that might make it a little bit more complicated. Not really, but a little bit. So what I'm going to do is convert this 1 centimeter to millimeters. And you recall this diagram here. So it was km, m, cm, and mm. And we thought 1 kilometer is 1,000 meters. So we would times by 1,000, times by 10, and times by 100 rather, and times by 10. Ooh, what am I doing? Control Z. Alright, so the way we get to centimeters, or from centimeters to millimeters, is we times by 10. So this is 1 times 10, that's the same as 10 millimeters. Now this 5 centimeters, 5 times 10 is 50 millimeters. This distance here is 2 centimeters or 20 millimeters. Alright, so let's start working out our perimeter. So we're going to say P equals, and again what I like to do is just highlight the edges that I've used. So that's 10 plus this part here is 15 plus this part here is 25. This part here is also 25. This part and this part, haven't got them yet, but let's do this bit here. Okay, that's another 20. Alright, so the same deal as before. Okay, this is 20 from here to here. This is 20 millimeters. So I'm going to look across the other side and note that this is 10 millimeters here and 25 millimeters here. So this distance here, the red part here, is in total 35 millimeters. Now if this is 20 millimeters, then this part here, has to be whatever is left to get to 35 millimeters, which means that this part here must be 15 millimeters. Alright, now the other part we need to work out is this bit here. Alright, now the way we're going to get that is we're going to note that this base here, this part here, is 50 millimeters. Okay, so we've got this bit here, the 15, and the 25, and that's going to equal 40. Right, now that means that from 40 we've got to get to 50. How do we do that? That's another 10. So this part here has to be 10 millimeters. Alright, and we've got everything we need now to find out our perimeter. So I'm just going to go plus 15 plus the 10. And I think that that's all of it, is it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Ooh, there's one missing. Okay, so it's got 10, 15, 25, 25, 15, 10, 20, and I forgot the bottom, which is 50. Alright, so let's stick them all together. 25, 50, 75, 95, 110, 120, 170 millimeters is our perimeter. So there you have it. These are the questions here which you'll find. I'll put a link into this resource here and you'll see the questions below, or you can just pause the video now and write those down into your books and get started. Good luck.